This is an extension of the square root method to solve quadratic equations. So we previously solved equations similar to the following by isolating the x squared. So your first step is to get x squared all by itself. So if you try these three in parts A, B, and C, you should be able to do those. And here's the answers. Okay, notice in part B, you don't get a nice answer. It's the square root of 8, plus or minus the square root of 8. But the other two give you nice integer answers. Okay, the next thing we look at is just extending that concept. So to solve the following equation, so suppose we have the quantity x plus 1 squared equals 16. Now notice how it's similar to x squared equals 16, but also a little bit different because of the plus 1 in the parentheses. So if that plus 1 wasn't there, we would just have x squared equals 16, and we would get plus or minus 4 for the answers. Well, that plus 1 throws things off a little bit. So what you want to look at is, how do you get rid of that squared? Well, don't you do plus or minus the square root? So x plus 1 equals plus or minus the square root of 16. And then what is the square root of 16? Well, that's 4, isn't it? So you could write x plus 1 equals plus or minus 4. Now it gets a little more awkward. We want to get x by itself. So how do you get rid of the plus 1 here? You subtract it from each side. Now what's awkward is that we have a plus or minus 4, which means that we have those two different answers there. So if we just write it like this, we subtracted 1 from each side, so x equals negative 1, and then plus or minus 4. Then you can break it apart into your two equations. So x equals negative 1 plus 4, and x equals negative 1 minus 4. And we could have done that in the first step. After we took the square root, we could have said x plus 1 equals 4, and x plus 1 equals negative 4. We could have done it that way if we wanted up in this step. And then subtract 1 to get 3, subtract 1 to get negative 5. Okay, so either way that makes the most sense to you, go ahead and do it that way. Okay, so you get positive 3 and negative 5 for your two different answers. And if you check those, notice what that's doing. 3 plus 1 is 4, and isn't 4 squared equal to 16? If you put negative 5 in, negative 5 plus 1, that's the negative 4. Squared is positive 16. So essentially, all you're saying here is, we know that if we square positive 4 or negative 4, that'll give us 16 for an answer. So what numbers can x be to get a positive 4 or a negative 4 in that parentheses? Well, if x is positive 3 or a negative 5. Next one, x minus 7 squared equals 25. So again, the idea here is, what can you square to get 25? Or how do you get rid of that square on the parentheses? You square root, do the plus or minus, okay, and that'll give you x minus 7 equals the square root of 25, which is 5. Now notice I added 7 to each side. So x equals 7 plus or minus 5. And again, this is the point where you could have looked at that and said x minus 7 equals 5, or x minus 7 equals negative 5. And then you go through and solve each of those. Again, whichever way you're more comfortable with is up to you. So you should get positive 12 and 2. And if you plug those in, 12 minus 7 is 5, squared is 25. And then 2 minus 7 gives you that negative 5. Square that, you get positive 25. Okay, so as we go through these, of course, they can get a little more complicated. But again, the idea is we have something squared equals a number. And to solve something squared equals a number, you do plus or minus the square root of the number. So in part C, that first step is to do plus or minus the square root of 36. And then you want to solve for x. So you can subtract the 3. And the square root of 36 is a nice number of 6. And then to solve that, you get rid of the 2 by dividing by 2. And that'll give you those two different equations. So negative 3 plus 6 over 2. That's coming from the addition sign here. And then the minus 6 is your second equation. So negative 3 minus 6 over 2. You solve each of those, and we get 3 halves and negative 9 halves, or 1.5 and negative 4.5. Notice it, I've just put the 1 in here. If you put 1.5 in, 2 times 1.5 is 3, plus 3 is 6. Square that to get 36. And the negative 9 halves, when you plug that in, that'll give you the negative 6. Squared, you get positive 36. Okay, so part D is very similar. I suggest you pause the video and try it. It's a little trickier because of the minus 2x there, but the same steps apply. Okay, so there's your answer for that one. Okay, and then moving on to the second page. Okay, now they get a little bit trickier because if you have the quantity x minus 3 squared equals 20, to solve that you do plus or minus the square root of 20. So x minus 3 equals plus or minus the square root of 20. And then to solve that, you have to add 3 to each side. Now what's different on this one is that the square root of 20 is not a nice number. The square root of 20 will give you an answer between 4 and 5. And if we put the square root of 20 in our calculator, so square root of 20, it just gives us 2 square root of 5. Now, you say, well, gee, Mark, that looks really different. Your calculator will actually simplify the square root for you. I do not expect you to do that, but you can, in place of the square root of 20, do 2 square root of 5. This is not part of this class, but what your calculator is doing, you can multiply 4 times 5 to get 20, but it's a square root. So the square root of 4 is 2, and then the square root of 5 you can't simplify, so you just leave it. So that's what your calculator is doing. So I'm just going to leave it as a square root of 20. And the wonderful news is that that is your final answer, because you can't simplify the square root of 20 anymore. Now, if you wanted to estimate what your answers were based on rounding to the nearest tenth or the nearest hundredth, okay, what you could actually do is break them apart into the 2 equations. So 3 plus the square root of 20, 3 minus the square root of 20. And then if you wanted to put that in your calculator, we could do 3 plus the square root of 20. And I'll just do the one answer for time. So 3 plus square root of 20, well, it'll give you 2 square root of 5 plus 3. If you want to round it, use your double arrow key down here in the bottom right, and that'll give you the decimal 7.47. So 7.47 to the nearest hundredth, or 7.5 to the nearest tenth. Okay, and you can do a similar thing for the 3 minus square root of 20. Okay, so moving along, you can try part B in this one. Notice you have to get the squared term all by itself. So subtract the 6 first. Okay, and then do plus or minus the square root. Okay, and again, this is the acceptable answer. That's the exact answer. And you can also write it in these 2 ways where you actually separate the plus and minus into 2 different equations. That's fine to do it that way. Okay, so if you go through and try the rest of these, I'll put the answers up. And these are tougher questions. Okay, these are not obvious to do. But again, isolate the squared term and then do plus or minus the square root. Okay, they're not all going to fit on here, but there's C and D. Now notice in part D, I had the square root of 17/4. Again, don't make that a decimal because you don't want to round anything here until the very last step if I ask you to. But when you do the square root of 17/4, remember it's a square root of the top, which is square root of 17. We can't do anything with it. And then the square root of 4 on the bottom is just 2. So that term turns into square root of 17, all divided by 2. Okay, and then here's the answer to part E, so you can see all of that answer. So that's an extension of the square root method. It's not easy, but once you get the hang of them, it's not too bad. Don't overstress about getting every single one of these right. If you can do the more basic ones, then you'll be in pretty good shape. Okay, so if you can do like all up through like 3A and 3B, okay, then you're in pretty good shape.